neutral to do this, almost what the white coat was meant when to do it. So then that
Oh, like what's the how do people respond to authority? Interesting. Yeah. All right. So how did the homework assignment go?
I don't know why.
So easy. Well, the more important question is, did you at least have some level of fun doing it? That's what's most important, as long as you were also tormented. Because giving the assignments is like my version of an electricity experiment. All right, so shut up. All right, let's take a look at some of these things here. All right, so homework was to make it so that our let me hide this thing real quick. Hide floating meeting controls. Make it so that our guy could go towards the exits, right? And then when he hit an exit, he would where do we stop the assignment? He would load into another scene and just be at the center. Okay, so is that it? Is that the assignment? Okay. Same room. This is our template for the room. This guy's called a dungeon room. So every single, like when I hit this door, it should reload the dungeon room scene. A brand new, fresh dungeon room scene with the dude in the middle. No, it would you would load. You have two options. Yeah, you could either create a new instance of this scene, loading the scene, or you could only have one scene and reset it if you wanted to go that approach. The approach I'm going to take is you are loading another scene. It is a physically different room, even though it looks identical. All right. So let's start off. I'm going to put our dude. I was messing around with this the other day. Let's just get him placed somewhere. All right. So we're going to put him at 0, 0. Let's see what he does right now. All right. So right now he goes off. Although I think for where I left it for you guys is where's my trigger. I think your current state is this one, where if I hit north, he slams into the door. Is that right? All right. So what we want to do is we want to create a scenario where you can go north, south, east, and west. So let's go update our code from for that. And that is in our. Forget about the center controller thing here for a second. All right. So we have if we press the up arrow, we're going to head towards the north exit. So what I did is I made our game know about all the exits: north exit, south exit, east exit, west exit. Made them public so I could drag those into the script. You go out here, you click on player. You see that the player has a controller script and he knows about all the exits. So from my initial perspective, the main reason to know about the exits is now I know their location. And I know what location I need to move towards. Make sense? All right, so if they press the up arrow, we're going to move. Let's see, I'm already giving away some of the farm here. Let me get rid of. Give me a moment. Okay. All right, so press the up arrow. We're going to head towards the north exit at whatever our movement speed is. So we press the left arrow, we're going to move towards our west exit at whatever the movement speed is. Right arrow, east exit. Down our arrow, south exit. All right. And what are we doing to get towards that location? We are applying a force. We're adding a force to the rigid body of the player to start heading in that direction. All right. So if I come here and now I hit left, it's going to go towards that guy. Oh, I already have them all. Give me a moment. I have to. There we go. So now this should be your starting point. Okay, so I go left, it's like that. I go right. It's like that. I go down. It's like that. And I go up. It's like that. All right. But what we don't want to have happen is we don't want to have them be able to kind of change their mind mid-turn. Once they choose an exit they're going to go towards, they're committed. Okay. So that means we have to have some way of knowing, are we currently rolling? All right. Just for a moment here, I'm going to just I've already put a couple of things in here in preparation. Take that guy out. All right. So as of right now, I can kind of pivot either direction. All right, but I'm kind of loosey-goosey all over the place. Well, we want our game to be much more structured than this. So once we choose a north, south, east, or west, we're going to be committed to that position. Okay, so with that in mind, we need to keep track of whether or not we've already started rolling. Because if we've already started rolling, any additional hits are not going to go anywhere. All right, so what I did is I went ahead, and I'm going to actually do this in my setup just to keep consistent. So I created a variable of type Boolean called isMoving. This is at the top of my player controller. And I'll go ahead and initialize this guy to false. I am currently not moving. Okay. Then down here, every single time that we start moving, we'll say this dot is moving is equal to true. So whenever we start going, we're going to mark the fact that we're moving equal to true. All right. So now what we have is we're now setting this variable to the fact that we are moving, but we're not preventing ourselves from pivoting directions once we're already moving. So we want to say if we've pressed the up arrow and we are currently not moving. So we can say and not is moving, or we can say if this dot is moving is equal to false. If you just like that version of it better. This is technically redundant because if is moving is false, I'm asking is false equal to false. Okay, but this is probably the way that reads better to kind of an intermediate programmer. All right, as opposed to saying and not this that is moving. That would be true when this is moving is false. Not false is a true. All right, but we'll leave it like this just so it spells it out a little cleaner. Not hurting anybody here. All right, so if we press the up arrow and we're currently not moving, then we'll start going in the direction and we will start moving. Similarly there, similarly there, similarly there. All right, so now we only allow ourselves to commit one of the four directions, and we won't apply any more force because even if we press the left arrow, right arrow, down arrow, whatever new arrow we press, because is moving gets set to true the very first time we do that, we will fail every single one of these Boolean expressions. What's a Boolean expression? Any expression that boils down to a single value of true or false. And since we're using an and here, both things need to be true, so we'll fail every single time, right? As soon as we set this guy to true, this guy will be false forever and ever. All right. So now we're in a situation where I can only go one direction. So once I start going north, it doesn't matter what other arrows I push. We'll do it again. And once I start going west, it doesn't matter what arrows I push. All right. Do it again. Once I go south, doesn't matter what arrows I push. And doesn't matter what arrows I push. All right. So far, so good. All right. Now, again, the mindset we want to have here, now hopefully you're going to see this here in a few minutes, is we're kind of, I mean, yes, we're programming, we're writing logic and things like that, but at the same time, we're also kind of playing in the sandbox that is the constraints that Unity gives us. So we're kind of playing this almost, it's a video game of writing video games. All right. And I think you'll see that when I challenge you with something here in a few minutes. All right, so the next thing that should happen is we want to become aware of when we hit one of those exits. All right, now our player has a sphere collider on it, so it knows how to collide with things. And all of our exits have colliders on them. Now, if we go ahead and we turn our player sphere collider on, oh, all right. So when we turn that to is trigger, what do we see happen? So our player fall through the floor, right? Why did that happen? So we have two different ways of handling colliders. We can either let a collider govern physics on a rigid body, right? Where we just let, you know, like when we have this turned off, you'll see when I roll north, we bang into that exit and kind of bounce back, right? We didn't code that. That's Unity applying physics to these rigid bodies and whatever the mass is. If you have ever actually looked in here, when you look at your rigid body, notice it has like a mass and a drag and angular stuff and whether or not to use gravity, all sorts of stuff that might make it slam into things harder or softer. All right. And things that might impact the automatic physics response. Okay. But now in this particular case, we're not really looking for that. We want to visually see our guy hit that exit, but then we want him to, you know, zoom into the next room, right? Okay, head into the next room. So I don't really need a bunch of ping pong bouncing around. Okay. Now we do want our player, though, to be able to go along the ground. So if I turn the player's sphere collider to a trigger, well, all of a sudden we now have a problem because he falls right through the floor because no longer is physics automatically playing a role of keeping him on the ground. Okay. If I become a trigger where I'm saying programmatically, I handle the code behind my controller handles what happens when I collide with stuff, and I don't write any code to govern it, I fall through the floor. All right, because I'm not using normal physics. If I go to my 4 exits and I turn on a is trigger there, notice I highlighted all of them so I can set all of them at once. Are they going to fall through the floor? Why not? Go ahead. They're not rigid bodies. Rigid body says, apply physics to me. So these guys aren't rigid bodies. So they have colliders, and they can act as a collider that a rigid body can bounce off of. Actually, you don't even need rigid bodies for colliders other than the fact to let physics kick in. Okay. But these guys now all have a collider, which they had before. But what we've done is we have programmatically, well, we've mentioned here that we want to handle collisions associated with these guys using the using our code instead of having physics do it. All right. So now we'll see when I go north, I roll right past that dude. And now I'm falling out of the sky. Okay. Because no longer is it just applying whatever physics should happen. Now it's like, hey, I'm going to send some signal that you entered this trigger, entered this collision area. If you want to do something about that, you do something about that. Okay. All right. So we want to find out who becomes aware of this. We want to find out who becomes aware of this kind of trigger event. So I'm going to start off. I'm going to go into my script for my player. Notice the player sphere collider is not a trigger. That's turned off, so he has physics associated with them. We want to know, does he become aware of the message that we just bumped into a trigger? So we'll go in here. We're in our player's controller. We can just go into an open spot here and go to the on trigger enter. And for right now, we'll just say, I hit something. All right. So now let's see what happens. I'll go ahead and click over to the console here. We'll start running. Okay. So it says I hit something. So even though the trigger was put on the box colliders of our exits, our player becomes aware that a trigger was entered. Now, specifically, he might be interested. Now, keep in mind, well, in this particular case, we know we only have 4 triggers in our scene, right? We happen to know that we only set the colliders for our 4 exits to triggers. So we know that we definitely bumped into an exit. But if we want to use good programming practice and we want to have the ability to have some other triggers or something, for instance, maybe in a little bit, we're going to be putting some monsters in here or something like that, that if you bump into a monster, all of a sudden you go to the attack sequence, right? You don't quite make it to the exit. Okay, now you go into the attack scene. And if you want to get to that exit, you got to clear the way first. All right. So we might have a couple of different kinds of triggers we're going to run into here. So what I'm going to do here is I'm going to highlight my 4 exits. Again, they're still all triggered. I'm going to tag these guys because I want to be able to ask the question, are you an exit? Okay. So I'm going to tag him. I'm going to add a tag. And we're going to call this tag exit. All right, I'll go highlight these guys again, and then we'll do the drop down and select all those as being exits. Make sense? All right, so now they're all exits. Let's go and see what we get out of that now. So we're going to say I hit something, and then we'll go ahead and say print other dot tag. Other is the variable that comes with this. That is a collider. All right. We can ask a collider what its tag is because it inherited that tag from the game object associated with it. All right. Otherwise, if we want to spell it out, we can say other dot game object dot tag and find out, is the thing I slammed into. We're going to be asking a question about it shortly, but right now we're just going to say, let me know what I hit. But remember, this guy only gets called if we entered a trigger. And right now there's only one kind of trigger in our game, and that's our exits. All right, but let's prove to ourselves that we do get that information about the exit being the tag. So there is I hit something and the tag is exit. All right. Now we only want to do something if the thing we ran into is an exit. So we're going to wrap this in a question, right back to day 1 of 200. Right? Remembering things, asking questions, repetition. So we're going to ask a question about this dude. Steal that line. So we're going to go ahead and say if that tag equals exit, where we compare strings using the equals function, just like we do in Java. So if that tag equals exit, we're going to say print, I hit an exit. It's proven to ourselves that we got in there. So let's look at our console down here. Hit play. Start running. Ah, I hit an exit. All right. Now, that's not what we want to do. We don't want to just scream that we hit an exit. We want to go ahead and just real quick, I want to test something here. Just so I can give some explanation. Remember in Java, if we couldn't use the double equal sign for comparing strings because it was actually comparing the memory addresses behind the scenes. But when we first introduced that, we actually saw that if we had like a string s equals hello, and then we said, is S2, is that equal hello? And sometimes it did work. It worked because we set it equal to the same string literal that was in literal space in memory. Okay, but in this case, the only place we've introduced this string literal exit is in the names of our tags. We don't necessarily know the behavior of how that gets set up. All right, so we're going to say, is our tag equal to exit? It is. So you can use the double equal sign. Now, I would never do this. Just like in Java, I'm asking the question, is the contents of this string equivalent to exit? Otherwise, decent chance, and we can run some more experiments and find out it's possible the double equal sign's been overridden to actually be a dot equals in here. At the very least, dot equals does compare the contents of our strings. Go ahead.
Yes, says something where you hover over other whenever you use equals. There's something about imposition. You have to hover over other.
Oh, this guy?
Well,
Oh, this guy.
says it when I use dot.
That's inefficient?
No, it says the double equals. Comparing tags, double equals.
Okay. All right, so yeah, if you say comparing tags using double equal signs is inefficient, potentially this is because they have overridden the double equal sign for doing the comparison. So it actually is having to do some like kind of scope lookups as it's walking up there. Let's just say what it says I can use the compare to method. Typically in most languages, compare to comes out to a number. So you would say compare to hello equals 0. 0 means they're the same. Let's see, what does this guy do? Oh, no, this guy literally just compares them. Oh, it's called compare tag. A lot of times there's a string method in programming languages called compare to that allows you to compare a string to another string, and it returns something less than 0 if the calling string should come alphabetically. It's actually called lexicographically before the string you passed in parameters. Something greater than 0 if it should come after that, or equal to 0 if they're the same. So you can use compare to compare it. So it looks like they have a built-in function called compare tag that, from their perspective, is the most efficient way of comparing tags to strings. Whatever. So dot equals worked fine. Chances are this guy uses dot equals behind the scenes and just makes it so that you don't have to worry about it. All right, well, let's test this, make sure it still does what we want it to do, because that's what's most important, is it behaves the way we want it to behave. So there we go. It's an exit. All right, so what do we want to have happen if it hits an exit? We want it to load our scene. Okay, so Now, I already put the scene manager in here. We had that in class last time. So we'll say scene manager dot load scene. And then we give it the name of the scene. And what's my scene called? Dungeon room. Scene manager, load scene, dungeon room. And this is going to happen as soon as we enter that trigger. Now, there's several different events that we can associate. So we could say on trigger. Notice we have an on trigger exit, on trigger stay. So if we're just chilling in there, we can do something. There's particle triggers. I don't know if we might do something with particles when we have like damage hitting our particle systems. We have damage hitting our monsters. You know, when we're just dropping the hammer on the rats. All right. But there's several different events we can respond to there. This idea is called event-driven programming. All right. Whenever the program itself or the tool itself raises an event when something occurs, and we basically are set up to be a listener for those events. All right. And when we hear an event, we can then say, is this an event I care about? Right? If you're about to run a race, okay, let's say you're a distance runner or something like that. What do you wait for? You wait for the pistol to shoot for the go. You know, whether it's a whistle or a gun. I don't know. Do they still use guns these days? That seems like it'd be, yeah, starter pistols. Huh? Just give it time. Give it time. But in any case, when you're standing there on the starting line, you really care about when that thing goes off because it's time to go, right? Yet if you're waiting in line for a hot dog, you probably don't care about that event all that much, right? Even though you might hear it, you might hear about it. That's kind of event-driven programming. All right. So when we run into one of those triggers, what's going to happen? We want it to go ahead and reload the scene. We're loading a duplicate scene of this guy. All right. Does that solve the homework? Okay. So we would now say that, okay, well, you know, that's good enough. But what I want to have happen is I want to see if we roll to this room to the north, I want to see myself roll in from the south. Make some sense? All right. So let's actually handle this trigger a little differently. Rather than, because as we have it set right now, as soon as we touch that trigger, our guy is gone. But what we really want to do is we want to create this idea that, okay, I went through the door and then I'm going to be coming through another door. So I actually want to maybe have this happen when I exit the trigger, not when I enter the trigger. That way I can see myself kind of disappear into the door. Make some sense? So on trigger exit, just change the event we're interested in. All right, so now we rolled through and then bounced back. So yeah, it seemed a little bit more legit, right? Okay. But now what we want to do is we want to have him roll in from another position. Okay. So I need to get his location set up correctly such that he rolls in from the right place. Really what I want to do is I want, when our player lands here, I want his new position to be right on top of this guy. Now, I already know about all these dudes, right? Who knows about those exits? Right now, the person who knows about those exits is the player. I believe that's who knows about it, right? The player script. It is this player's controller that knows about all of our exits. But we need to somehow make him aware of the exit he just took to get to where he is right now. Make sense? Well, how do we do that? How do we make sure that when the second scene launches, okay, I'm on scene number 2. When the second scene launches, the player can say, okay, everybody wait, where did I just come from? What do you think? Suggestions? Using only the tools we've learned about in class so far. Go ahead.
Would you use the?
All right, what kind of animal was master data? Singleton. So maybe this global variable thing could be handy, right? Could be handy if it was a single, if we let that singleton know on our way through the exit, we said, hey, I'm going through the north door, or I'm going through the south door, east door. I now have recorded that information so that when I start that next scene, I can jump up to the singleton and said, okay, how did I just get here? And make some decisions about that. Make sense? All right, so with that in mind, how do we know which of those doors we went through? What do you think? Oh, really, the question I want to say is, how do I set my singleton to the correct door value? How do I know that I went through the north door versus the west door versus the south door versus the east door? All I want to do right now is I'm going to ultimately set some string variable up in the singleton equal to north, south, east, west. And that's going to be the variable associated with where did I come from. So if you want to see me go ahead and add that, I'll go into master data here. And I'm just going to create a public static string. Where did I come from? And we'll start that off as nowhere. All right, actually, let's just start that off as a question mark. All right. So I want to be able to say where, master data dot where did I come from equals to north, equals to south, equals to east, west. How do I determine, as right before I load the scene again, which door I'm currently going through?
Maybe launcher branch would code the master data dot.
So where did I come from?
Yeah. That's what you do for each. Specify which.
How do I know which one it is? She's right. This is how I'm going to set it. I want to set it to, for instance, north, if I just went through the north exit. But how do I know I went through the north exit here?
And from each exit you went through, that adds that number. So like if you went to the north, it adds 1. If you went to the south, it adds.
How do I find out if I went through the north? We're making all these assumptions that I know which exit. I can visually see what exit I rolled through. But go ahead. Could do that. Could make different tags for the doors. So instead of them all being exit, we could say that's the north exit, the south exit, the east exit, the west exit. Go ahead.
Well, your exits already have the name. So you can just do game object.
Okay. So we could use the game objects built-in thing. This is similar to your tag thing, and ask what's the name of that variable. What else?
Just throw it in from the first time so that you're going up, going north.
Ah, that's not a bad idea. So we could, since we know that the nature of our game is such that as soon as we hit one of those arrows and we start rolling, There's no stopping. Okay, at least for right now, because we don't have monsters to bump into, right? So once we start heading north, we know we're going to go through that north exit, so on and so forth. Could do it then. All right. I don't like any of those. How else? Another value.
You could try doing the if statement and try and get it to recognize, what the specific game object is, but I've tried that before and it's not accepting it because other doesn't have a definition for game object or something.
So if other dot game object is equal to this dot north exit,
There's screen then.
something like that. All right, and then why don't we go ahead and right at the beginning of start here, we will print out master data dot where did I come from? Very first time, this should be a question mark. And I'll just make sure I go north for the first time. I'll save this. All right, so there's my question mark initially. I'll go ahead and hit that. And now it says north. All right, but if I run it again, and I go to the west, now it's still a question mark. So we saw from that conversation that there are several different ways we could figure this out, right? One's not necessarily better than the other. I guess I probably like this current one because I would rather compare a memory address than compare a string. I think it's probably more efficient, but they're all going to get the job done. All right. So your suggestion was let's create different tags, unique tags for the doors. His suggestion was, well, we already have variable names for the various doors. They already have north exit, east exit, whatever. Let's just ask the game object, what is your name? Because that's what's associated with that. That's just as good as the tag, maybe better than the tag, because kind of tags, the use case for them is tell me what kind of animal I'm dealing with, when really in our case that the exits are kind of all the same type of animal, right? All right. The idea of setting it as soon as we have our intention of heading in a certain direction, not a bad idea. It does give us a little bit of limitation for if we run into monsters, but we could always say, hey, I bumped into a monster. So what's going to do? What are we going to do? I'll just set it back to a question mark. Okay, I haven't gotten going yet. Something like that. All right. But in this case, what am I doing? I'm going to say, look, I just ran into a collider inside my on trigger exit. And I can say, is that guy the same memory address as my north, south, east, or west? All right. So now, so we'll put several of these things in here. Tactically, we're gonna have that last one just be an else, but we're not going to. North, south, east, west, all right. And I'll go ahead and still print it out just so we can test all four and make sure it's behaving the way we want it to behave. All right, so we initially get a question mark. I'll head to the west. And now we get a west. I'll head to the east. Now we get an east. Except we still get an easy. I misspelled east the wrong way twice. Then we got the south and we got the north. All right. Seems to be working correctly. Just need to update my thing to say east. All right, so now we are setting that that thing correctly. Our singleton, remember singleton's a design pattern that says it's a good idea to store things in one place that need to be accessed from multiple entities. In this case, I have multiple scenes that all kind of need to know some information about the scene I just came from. All right. Now, one suggestion we had as part of that conversation is, oh, why don't we just let our singleton know about our game objects? Well, can we do that? How would we do that? How can we let our singleton know about the north, south, east, and west? We go back in here. Where is my singleton code? Where's that code? Where's that script attached to? Not attached to anything. Remember, we specifically went in to this guy and said, you are not a mono behavior. Since you're not a mono behavior, we can't attach you to game objects. Therefore, he's not actually in the scene. He's this global entity. That's what allows him to persist between loads of our different scenes. But that also means we have no way of dragging our game objects in there, right? How could we let that guy know about our different game objects, though? Maybe at the very beginning of player script. Since the player knows about all those exits, we could just set a bunch of game objects inside of our singleton equal to those things programmatically. We would have to teach our master data because right now he doesn't know about game objects. So I'd have to bring in the namespace that knows about game objects, and we can just grab that pretty easily from over here. It's probably this Unity engine deal right here, but might be one of the other ones. Okay, but right now we don't need that, so we're going to keep it as clean as possible. All right, so what do we want to have happen next?
For the player controller, if the master data equals a certain value, it'll set it to a certain position at the start.
Okay.
Yeah, I want to roll out the exit, so I'll program move
Yeah.
down to.
So next homework. When our dungeon room scene loads, if we are coming from a known exit, position our player appropriately and have the player roll toward the center of the room, stopping once they hit the center. So they are prepared to make their next move.
Sure, the move values variable that we use to determine whether it'll accept inputs or not from the keyboard. We should make sure that stays as a true until it gets to the center of the room, so people don't go meandering off.
Well, so what you're asking is the is move thing?
Yeah.
Is move gets reset. Remember inside of our code here for player controller, it automatically happens. Every single time this player controller initially loads, and it loads one time per instance of our scene, it will get set back to false. It's not getting set back. This is a different version of is moving from the previous scene's version of is moving. So basically all our behaviors in this scene reset. We just need to make sure that if we exited through the north, that our player comes rolling in from the south. We exited from the west, comes rolling in from the east, so on and so forth. Make sense? And then we want them to stop in the middle of the room so that we can do this again. Right? Move north, south, east, west, and move through our dungeon. Okay. So let me go ahead. Let me make sure all this is. Sure all of this is saved. And I will upload to GitHub. So we'll say updated for homework. I'll just leave it at that. Commit to main. That commits it locally. Push it to origin. Now it's in the cloud. All right. So I'll put the homework assignment up. Everybody make sure everybody understand what I'm asking you to do. Roll in from the north. Should come in from the opposite way. If I exit the room south. Correct. Submit the link to your code as well as the cell.
So this contribute one trigger as it's, set to the exit, so it doesn't keep us in the flow. That would.
Interesting.
Oh, like, that's not fixing.
He knows.
I mean, ours.
That sounds like a fun.
So we could pull things off there.
All right. I will see everybody on Wednesday. And good work, everybody who participated in the hackathon. Think the winning team got $300 split.
So, actually, get it.
Checks in the mail.
So it's up to you.